Hello there, Mr. Sutton here with the AB Calculus 3-8 Extra Practice Number 1 solutions on implicit differentiation. For the first problem here, it would be possible to isolate y, but it'd be kind of annoying. It's really faster just to do implicit differentiation here. So doing the left side, we're going to need the chain rule. That will be 3 quantity 3y plus 1 squared times we have a tail of 3 times we have a tail of dy over dx, because we have 3y there that you're taking the derivative of. Remember with impdiff, whenever you're taking the derivative of y, you get a dy over dx. All right, right side, we've got 4x, and that's it. So all we have to do to isolate dy over dx is divide both sides by all this stuff here. It's all being multiplied already. So we've got really 9 times that stuff squared, and that's all going to go in the denominator under 4x. For number 3, it would be a huge pain to try to isolate y before taking the derivative. So let's just take the derivative now and do a little implicit differentiation. Going from left to right, we've got 3y squared dy d over dx minus dy over dx equals 2x. And then for this one, we're going to need the product rule, so I'll make a little box and ribbon for this. We've got 2x is one factor, and y is the other. So we've got derivatives of 2 and dy over dx. Using my ribbon, that gives me 2y plus 2x dy over dx. And finally, we have 2y dy over dx. All right, whole bunch of dy over dx's here. So I'm going to move these two terms that have dy over dx's over to the left side by subtracting, leaving only the 2x and the 2y over on the right side. Next, I can factor out a dy over dx from everything on the left side, so that leaves me with 3y squared minus 1 minus 2x minus 2y in a parentheses. And now I'm just going to divide 2x plus 2y by all of the stuff in that parentheses, and I'm done. For number 7, isolating y actually wouldn't be too bad, but I'm going to go ahead and use impdiff anyway, because this is the implicit differentiation homework. So on the left side, we've got cosine for our derivative. On the right side, I'm going to go ahead and use the product rule for this. So we've got 2x cubed and y. Derivatives are going to be 6x squared and dy over dx. So using my ribbon here, I've got 6x squared y plus 2x cubed dy over dx. And then just 2 steps to get dy over dx by itself. So subtract the 6x squared y, and then divide both sides by 2x cubed, and we're done. On this problem, we're given this equation here, and we want to figure out y prime at the point 1, 2. So let's take the general derivative and then plug this point into it. I'm going to need implicit differentiation for this, because I can't really isolate y. So let's see here, xy squared derivative of that's going to require a product rule. So we have factors of x and y squared for this one, derivatives of 1, and this is going to be 2y dy over dx, because we've got to use the chain rule, y is an inner function. Multiplying that out, we've got y squared plus 2xy dy over dx. Next, I have to take the derivative of 2xy, which also requires the product rule. So another box and ribbon for me here. Factors of 2x and y. Derivatives of 2 and dy over dx. Ribbon for multiplying that out. We've got 2y that we're adding there, plus 2x dy over dx. And then finally, we've got the derivative of 8 on the other side, which is just 0. All right, time to isolate the stuff with dy over dx. So I've got 2xy dy over dx, that's staying on the left side. Also, I have this plus 2x dy over dx. Moving over to the right side, I'm going to have a negative y squared over there, along with a negative 2y if I subtract both of those. On the left side now, I can factor out dy over dx, leaving me with 2xy plus 2x. I could factor a 2x out as well, but really I just want to get dy over dx factored out so that I can leave it on the left side here. Dividing by this stuff now, I've got negative y squared minus 2y over 2xy plus 2x. And at this point, I have to go ahead and plug in the point 1, 2 for this. So evaluating this derivative at 1, 2, In the numerator, I've got negative, let's see, y value of 2 being squared minus 2 times the y value of 2. Down below, I've got 2 times the x value 1 times the y value 2 plus 2 times that x value of 1. Back in the numerator, I've got negative 4 minus another 4, so that's a grand total of negative 8 up there. Down below, this is going to be 4 plus 2, which is 6. Negative 8 over 6, that's going to reduce to negative 4/3, which helps me match the answer choice B. For this problem, they want to know which of the following is true about this curve at the point 2, 1. So for all of these, they're talking about the tangent line and the derivative of this curve at 2, 1, which means we're talking about the derivative of this thing. So we essentially need to take the derivative of this. We're going to have to use implicit differentiation to do it because we can't isolate y. And we're going to have to plug in 2, 1 and see what happens. Now, there are some conclusions you can make, or at least some choices you can eliminate here. So they're saying here, for example, that this does not exist, derivative does not exist there, and the tangent line is horizontal. Well, if the derivative did not exist, the tangent line would be vertical. So choice E you can eliminate right off the bat because the behavior of the derivative and the tangent line slope don't match up. And let's see here. Let's see. Choice C we can't really eliminate. B we can't eliminate. And there is no tangent line at that point. Well, I'm not sure about that. I mean, 2, 1 is going to be defined if you plug that in. So A is probably also suspect. But enough stalling. Let's take the derivative. Going from left to right here, we've got derivative of x squared, which is 2x. Derivative of negative xy is going to require a product rule. So for my box and ribbon, I have factors of negative x and also y. Their derivatives are going to be negative 1. And that other derivative of y is going to be dy over dx. So using the ribbon to put all that together, we have negative y minus x dy over dx. Next, derivative of y squared, that's going to be 2y times a tail of dy over dx. And that's going to equal the derivative of 3, which was 0. All right, let's see what stays on the left side here. We're going to keep everything with the dy over dx on the left. So negative x dy over dx plus 2y dy over dx. And these first two terms actually move over to the right side. So we have negative 2x that this stuff equals here. And also we're going to add y to get that over to the right side. Now I can factor out a dy over dx. That leaves me with negative x plus 2y on the left side. Dividing, I have negative 2x plus y over negative x plus 2y. And at this point, I have to actually plug in the point 2, 1 to see what happens here. So evaluating at that point, we've got in the numerator negative 2 times that x value of 2 plus the y value 1. Down below, we have negative x value of 2 plus 2 times the y value 1. In the numerator again, we have negative 4 plus 1, which is negative 3. Down below, this is negative 2 plus 2, which is 0. So this actually does not exist. And since our derivative does not exist, that means we are going to have a vertical tangent line, which means we need one of these does not exist answer choices, specifically the one that says the tangent line is vertical, so choice D. For this problem, we want the derivative of this curve at 1, 1. So using implicit differentiation, because we can't isolate y, Going from left to right, derivative of x is 1. Derivative of 2xy is going to require a product rule. So here's the box and ribbon. We have factors of 2x and y, and derivatives of, let's see, this will be 2 and dy over dx. Multiplying that out with the ribbon, we've got 2y plus 2x dy over dx. On to the next thing, we have negative y squared's derivative, which is going to be negative 2y times dy over dx. And that's going to equal the derivative of 2, which is 0. All right, now let's keep the stuff with dy over dx on the left side. So 2x dy over dx minus 2y dy over dx. Other stuff is moving over to the right side. So we have minus 1 and minus 2y. I can factor out a dy over dx on the left side. Dividing everything now, I've got negative 1 minus 2y over 2x minus 2y. I still need to plug in the point 2, 1 to this derivative, though. So let's go ahead and do that. Up top, I've got negative 1 minus 2 times the y value 1. And the x and y are actually the same thing here. Down below, I have 2 times the x value 1 minus 2 times the y value 1. So up top, this is negative 1 minus 2, so negative 3. Down below, 2 minus 2 is 0, which is, let's see, going to give us an undefined answer here. So that means our slope does not exist. Choice E.